Hi, I'm Bob Van Til, Chair of Industrial Systems Engineering. So I am Chair of Industrial and Systems Engineering here at Oakland University. I'm joined today with two of our faculty colleagues. And so what we're going to do is we're going to give you a quick overview of Industrial and Systems Engineering, what it's all about. We're Industrial and Systems Engineering. Historical name is just Industrial Engineering. Systems engineering is a recent addition. We'll see in this talk why that has been appended on, why most programs have added the and systems to their titles. A marketing nightmare of a name. Industrial engineering is not user-friendly. People hear that and think, oh boy, I'm going to be working out in an automobile plant all day building cars, and I don't want to do that. And no, you're not. If you want to do that, working in an auto plant building cars, go to the School of Business. Those are the operations people. They run, they operate the plant. Engineers make way too much money to do that job. What industrial engineers would have done is they would have designed the factory, the manufacturing system. So the roots of industrial engineering goes back to the mid 1800s with the first industrial revolution. Manufacturing starts coming into play, and these are complex systems that folks quickly realize need to be engineered to work properly. And so the people who engineered manufacturing systems were titled industrial engineers, hence their root is there. Now it's expanded way past manufacturing, as you'll see in this talk, and that's where the end systems comes into play. Formal definition, like all domains of engineering, you'll find a very formal definition available. The big difference you'll see is industrial systems engineers work closely with people, much closer than all the other domains of engineering. We're kind of the people domain of engineering. Kind of leads to a better definition. It gives you choices. In all domains of engineering, your first job will be over here. Very focused on technology, taking all the math and science and engineering skill sets and tools and techniques and programs and toys and applying it to solve problems. And in industrial engineering, you can do that too. But one thing industrial engineering lets you do that the other domains won't is you go over to the management side because it's the people side of engineering. So in fact, you walk into any business school in the US, you will find industrial systems engineers on their faculty. Oakland's business school, I believe, has 4 or 5 on their faculty. So you can be very techie with industrial engineering or very management focused. That's your choice. It gives you that choice to do that. The other domains will not do that. John Katuna graduated a few years back using our Industry 4.0 tools. He's now down to General Motors. As his first job at General Motors was over here on the left, very tech focused, taking Industry 4.0 digital twin, digital manufacturing tools, designing manufacturing systems for General Motors down in Warren at their big research complex. So he was very tech focused because that's where he wanted to be. Anthony graduated about a year later. He was a management guy. He wanted to work with people and do management. First job walking out the blocks is with Ernst & Young in downtown Chicago doing high-level management consulting. So many engineers move from left to right. Industrial engineers do it much faster, much quicker. And as your walk-out job, you can be anywhere along that. And that just doesn't happen in the other domains. So this is one of the ways industrial and systems engineering gives you choices. All domains of engineering, you can do a lot of different stuff. We educate you as a generalist. You can do a lot of different things with it. This is true in all domains of engineering. You know, when you were in high school, you had a mechanical or electrical engineer come in to talk about what they did. Don't think that all mechanical or electrical engineers do that. That's one small thing of myriad of things you can do with the degree. And the same holds with industrial systems engineering. Don't think it's just one little thing. Educating has gotten pretty expensive. You got to have an ROI, return on investment, for it. And so one of the things you say is, hey, I'm not familiar with ISE. Maybe you are. Are there jobs? This is 2019 data from the United States Department of Labor. This is the latest. The 2020 data should come out in another month or so. They keep track of people working in all professions, in all areas. About a dozen different domains of engineering. What you see here is the top 6. On the left, you can see how many people in 2019 were working in the 6 top domains of engineering. You can see in the United States, there's 4 main domains of engineering, one of them being industrial and systems. At the same time, in the state of Michigan, this is how many engineers were working. And you can see industrial systems engineers are second only to mechanical engineers. We're one of the largest, if not largest state in terms of ISE employment. And so, yeah, there's a lot of jobs, good starting salary. And so you can really, you can do well in ISE. Of course, to go with that is supply and demand. In 2019, I'm going to have to try to dig up the 2020 data. It's pretty hard to get this data. These are how many students in the state of Michigan were enrolled in 6 different ABET accredited programs. Now, our program here is ABET accredited, mechanical engineering, electrical engineering, computer engineering, and Industrial systems engineering, all ABET accredited. Bioengineering, they're going for accreditation. They're just a brand new program. And so these are the total number of students in those accredited programs. CISC is a relatively small program. Again, there's 7 programs in the state of Michigan. Ann Arbor is the big dog at 400. We're at about 100 students right now. We're new degree to Oakland University. The engineering school go back to the 1960s, but ISC was launched in 2007. And so we're relatively new. We're about 100 students. We grew from 3 students at that time at launch to about 100 now. So we had about 10-15% growth every year. One thing nice is this past fall, actually, we grew 1%, whereas most programs, you've been seeing a lot of stories about, college enrollment taking big drops because of the pandemic. We actually grew by 1%. So we're currently about the 2nd biggest program in the state, tied with a couple other schools, with Ann Arbor being the largest. And we've had a nice growth pattern. So these are the number of students in those programs. In the 3rd quarter, these are the number of job postings in Southeast Michigan for engineers by the Workforce Intelligence Network. And you can see the scales are exactly the same here. So these bars fit exactly the same. And you can see the demand for industrial systems engineers is equal to mechanical, even though there's more mechanical engineers in the state. And that's because of supply. Normally, now you gotta remember, these are all students enrolled in the program, not just graduates. And so normally in the other domains of engineering, usually there's about 2 or 3 to 1 open positions for graduates per graduate. In industrial engineering, it tends to be about 12 to 15 to 1 open positions for graduates. And so there's a lot of jobs, they're very well-paying jobs, and there's a lot of demand. And this is true in solid and all of engineering. And in fact, the state of Michigan just released the Hot 50. This came out a couple of weeks ago. We got a link, we'll put up a link on our website, of the top 50 jobs between now and 2018 in terms of growth. There are 3 engineering domains on that list of 50 jobs. Mechanical engineering going up about 2.5%, electrical engineering going up about 2.5%, and the leader is industrial systems engineering going up over 8.5% between now and 2020 and 2028. And so there's a lot of projected growth in the domain too. Where do our students work? Okay, these are companies our students are either full-time employees at and or paid internships. Almost all our students have paid internships either in the summer or year-round. And you would expect a lot of manufacturing companies to be on this list. Yeah, a lot of the OEMs and suppliers, they make stuff, aerospace, defense, food manufacturing, HVAC systems, football helmet manufacturing, companies that make stuff, you expect them to be on that list. That's the industrial engineering kind of classical areas. You see supply chain, you start seeing construction, finance, life insurance, software, energy, hospitals. Industrial engineers work in all these domains. That's where the end system starts to come into play. The fact that they're emphasizing not just manufacturing, but other industries. If you think of a manufacturing system, it's a big flow system. Product flows through it and you operate on it. And so automobile assembly plant, some material and some people in technology start the car, pass it on to the next station. They work on a more 500 stops later, there's a car goes out the back door. It's a great big system that flows stuff through information and material. All these other systems do the same thing. Hospitals, patient walks in, checks in, gets sent to triage, gets sent to x-ray, gets sent to see a nurse, gets sent to see a doctor. It's a big flow system. Hospitals hire industrial systems engineers, not for the medical side, but for the flow of systems. You get into software, finance, life insurance. Product doesn't flow through those systems. Information flows through those systems. So industrial engineers look at the system level stuff. Supply chain companies. A lot of material flows through supply chains. Industrial systems engineers design those. So that's where the end systems is to emphasize the fact that it's not just manufacturing. Now we take the end systems really critical. We teach you concepts in systems engineering at Oakland University. Because of that, even though there's probably 50 or so programs called industrial and systems engineering in the United States, we're one of 5 of those programs that are ABET accredited in both industrial engineering and in systems engineering, because we take the systems side really seriously. In fact, one of our students just took a job in Oakland, California with this company right here. They're working on designing high-speed rail in California, and they're doing systems engineering work. So they hired her for the systems side. Industry 4.0, you may have heard of, we're in the 4th industrial revolution right now. It's going on. It's all about digital. doing things. These are called digital twins. These three different animations running right now are called digital twins. This is the first industrial revolution, again, mid-1800s, manufacturing has its roots. Second happens here in Detroit, mass production, Henry Ford. The third starts in about the 70s, automation. You start seeing robots and computer numerical control and programmable logic controllers and vision systems and all these technologies, automated guided vehicles, starting to appear in manufacturing. And they're becoming pretty standard these days. And so it's that revolution's kind of over, even though most people still talk about robots and things. And then the fourth one started in the mid 2011 is when they named it. We were actually in it before they named it. So we're very strong in it in education. We're one of the lead universities in the world in teaching Industry 4.0. I was invited to Germany last year to talk about how we integrate Industry 4.0, and all the companies were so surprised at the level of integration we have. And so it's about digital. With the Internet of Things and the Ethernet, you can get data now, and Industry 4.0 is all about using that data, collecting the data, using it to build digital twins, using it to apply artificial intelligence and data analytics to improve system performance. That's the fourth industrial revolution. So here you see three industry-grade tools. These tools are all industry-grade tools. Plant simulation here. This is called Process Simulate, and this is called Jack. On the top, you see a digital twin running of a manufacturing system. This system is in our Sharp computer-grade manufacturing lab. This is a plant sim digital twin. This is a student project that modeled the system and then made enhancements to it. This is how engineering goes out in the industry. Everything's digital now. Below it, you see ergonomics. Ergonomics is the physical response of the human body to motion and work. And so while this person's doing this, you can measure the stress in all the joints in the body. It's an easy task to do once. If you're doing this repeatedly in a factory all day, every 60 seconds, 8 hours a day, you can start seeing repetitive stress injury. A repetitive example, carpal tunnel. Type down the keyboard, no big deal. Doing that a lot, carpal tunnel starts going in. Those are called repetitive stress. So we teach heavily this tool. A lot of our students work in this ergonomics area. This is an official tool for Ford manufacturing. Ford Manufacturing's workers' comp, when they started using this tool, went from over $9 million a year to under $2 million a year because they required the use of this tool. So a lot of our students work in that area. Discrete event simulation, a lot of our students work with this tool. In fact, just last week, FCA or Stellantis now hired 2 of our students for their discrete event simulation group, specifically because they know this tool. They can't find other universities that are using these in their education program. This down here is a senior design project. It's a cell that we work with a local company. A team of our students were guided by a local company to design this cell. It's going to do General Motors plant, actually. And it's a robotics tool. And you can use it to design. What's really cool about this tool, it does collision avoidance. It'll tell you if these robots bump into anything. And so you can learn that in the domain without actually endangering a robot. Once you're done programming this up and doing all the engineering analysis, it'll write the robot code you can download through the internet and run the robots. So in the old days, robots would have been programmed by hand. Now you program in this animated environment using tools like this and running them. So this is a really big area for us, although we do a lot of other stuff. Learn more about us off our website. There's all kinds of information. Go to our website. We got a lot of articles, stuff about our students, videos. It's all about what is ISE and what our program is all about.